Okay, so today we're going to be talking about special right triangles. There are two types of special right triangles that we're going to focus on this year in trig. One of them is the 45, 45, 90. Okay, so it starts with a square. Now the square facts, obviously 4 equal sides, has 4 90-degree angles. So you see I've connected the diagonal from one quarter to the other. That creates two what we call isosceles triangles. Isosceles triangles means two sides of a triangle are the same. So if I have this triangle here, these two sides are the same, these two sides are the same. Okay? And then also what it does is it creates two 45, 45, 90. Well, these sides, these angles are still 90 with the triangles. But since these two sides have been cut in half, they are now 45 degrees. They still make up 90, but they're just cut in half because they're triangles now. Alright. So now we have two 45, 45, 90. 45, 45, 90 right triangles. Okay? So what we're going to do now is we're going to use those to figure out the length of the diagonal. We don't know what the length is of there. We know that each of these is 1 unit, but we don't know how long the middle is. Okay. So what we're going to do here is we're going to redraw the triangle, just one of them. Okay, so this is a 90 degrees. This is 45. This is 45. We know that this side here is 1. This side here is 1. We just don't know what that is. And that's what we're trying to figure out. Well, you probably use this. You definitely use this a lot. Probably you started using it in junior high to figure out lengths of a right triangle. And it's called Pythagorean theorem. Pythagorean theorem tells us the lengths. If we're missing one length of a right triangle, then it'll tell us what the missing length is. So A and B. A and B are the two sides that make up the right triangle. So this one here is going to be either A or B, and this one here is going to be A or B. In other words, it's legs. We call them legs. Well, it doesn't really matter, especially because since they're the same length. So if we say that they're both 1, so we're going to put 1 squared plus 1 squared equals, C is always going to be what's called the hypotenuse. The hypotenuse is the angle that's opposite the 90 degrees. It's always opposite the 90 degrees. So in this case, this right here is going to be the hypotenuse. It's always going to be the longest. Okay, so C, we'll call that C. Okay, so C squared. So for our right triangle, we're going to finish the math. 1 squared is 1. 1 squared is 1. So when I add them together, I'm going to get 2. Okay. So now I got to solve for C. So we're going to get C equals the square root of 2. We're not going to use plus or minus 2 since we're talking about length. Length is always positive. So we only care about the positive length. Okay, so the square root of 2 is the length of C. Now if you use a calculator, now I don't want you to do this on the answer. This is the answer I want you to use. From now on, I don't want you to do any decimals. Leave it as a root. Okay? If it's like the square root of 4, obviously change that to 2. The square root of 16 is 4. Square root of 81 is 9. Stuff like that I want you to change. But if it's like this, an irrational number, square root of 2, 1.414213, and it keeps going on and on. I don't want you to use this. This is not the number we're going to use anymore. That's just an approximation. I want you to use just the exact. Okay, that's especially important when we start getting more into trig. Okay, So now what we're noticing here is that there's a relationship going on. What you see here is that 45, 45, 90 are always going to be isosceles triangles, because two of the angles are always going to be the same. And then what we saw with the last problem was that the long side is always going to be root 2. This guy is 1, this guy is 1. So it's 1 times root 2. If this was 2, it would be 2 times root 2. If this was 3, if these guys were 3, it would be 3 times root 2. Okay, so the relationship between those is always going to be, these are the same, the legs are the same, and whatever the leg times root 2 will be the hypotenuse. Okay, so let's do a couple examples. First couple examples. Okay, so they want us to figure out what x and y are equal to. Well, first of all, we notice that, we'll say this is number 1. We notice that one angle is 45, one angle is 90, so that obviously, because a triangle can only have 180 degrees in it, that one has to be 3 as well. Okay, so this leg here is 3. That means the other leg has to be 3. Those are the two sides. Those are the two isosceles sides. All right. So now what we're going to do is we're going to figure out what this is. Well, if we know what the legs are, all we have to do is multiply them times root 2, and we'll get the hypotenuse. So 3 times root 2. Again, do not make that a decimal. Leave it as 3 times root 2. Okay. Number 2. So I'm going to kind of spin this around so it makes a little more sense to me. Okay, so I see this is the 45 here. That means this is going to be the 45 as well. So this is one of the legs. This is the other leg. So that means it's going to be the exact same thing. 2 times root 3. That means this, since it's opposite the 90 degrees, it's going to be whatever I got for the legs times root 2. Okay. So now, if you remember how to multiply, well, if they have the same, if they're the same root, this is square root, I can multiply. So when you multiply them, you're going to get square root 6. And then you get a 2 on the outside. Well, 6, there's nothing in there. If I break it down, if I break down 6, it's going to be 3 times 2, right? There are no pairs in there. There are no pairs that I can take out. So that's my simplified answer. I'm not changing it to a decimal. I'm leaving it like that. And this is the leg there. Okay. So now, the last two. Call this one 3, we'll call this one 4. Okay. So number 3. So number 3, I know, let me see, let me turn it around so it looks a little more, flip it around so it looks a little more normal for me anyway. Some of you might be able to do this without doing that, but for some reason I need to. Okay? So we know that these two sides are the same. We know that the 90 degree is there. So that means this is a 45 and this is a 45 degree angle here. The hypotenuse is what they've given me. So I know that the hypotenuse is 4. Okay. So now they kind of did the opposite. So now we got to go backwards. How do I go from a hypotenuse back to a leg? Well, if you remember, to go from a leg to a hypotenuse, I multiplied times square root of 2. I did it up here too. Oops. To go from here to here, you multiply times the square root of 2. But now we need to go from here to here. Well, what's the opposite of multiplying by the square root of 2? Dividing by the square root of 2. So what I'm going to do now is I'm going to take 4, the hypotenuse, and divide it by the square root of 2. Okay, that's the length. Problem is, if you remember, we can't leave a square root on the bottom. We can't leave any root on the bottom. It's called rationalizing the denominator. You have it in your notes from when we were in session. Okay, so to do that, I'm going to have to multiply by what's causing the issue. Well, what's causing the issue is the square root of 2. So whatever I do to the bottom, I have to do to the top. As you can see here, it's just the square root of 2 divided by the square root of 2, which makes a 1. So I'm just multiplying the fraction by 1. Multiply straight across. 4 times the square root of 2 is just 4 times the square root of 2, or 4 root 2. The square root of 2 times the square root of 2 makes the square root of 4, which is the same thing as 2. One last thing here. 4 and 2, those can be reduced to 2 over 1, which is the same thing as 2 root 2. Okay, so both of those are going to be 2 root 2. 2 root 2. Okay. Okay, so the last one, number 4, last practice problem. Number 4. Okay, so again, I'm going to kind of turn it, spin it around so it makes a little more sense. All right, so I know I have a 90, I know I have a 45, and I know I have a 45, and I know I have 10 root 2 here. Well, it's just like the last problem. The last problem, if we know what the hypotenuse is, to get to the leg, we got to divide by the square root of 2. Okay, so what I'm going to do here is I'm going to divide by the square root of 2. So I'm going to take 10 times the square root of 2, and I'm going to divide it by the square root of 2. So it's 10 times the square root of 2 divided by the square root of 2. I can rewrite this like this. It's the same thing, I just rewrote it. The reason I rewrote it is because if you look, the square root of 2 divided by the square root of 2, giant 1. So it's really just 10 times 1, which is 10. So that means x is 10, y is 10. Okay. So I'm going to post these notes, the notes we took, along with the assignment on Google Classroom. Okay. So I'm going to post both of these notes. Obviously, you'll have to fill it in, or you can just do it on a separate sheet of paper. You can use your notebook. You don't have to print these out. You can just do it on a separate sheet of paper as well in your notebook. Okay.